Hey everyone, I haven't made a video in a while, but I always have these cool things I want to teach, and one of them is virtual machine clustering and some parallel programming. So this was a workshop that I did a few weeks ago, and I didn't make a video of it, but now this video on YouTube will be my workshop recap. Now to go over some of the slides I presented, I first related to supercomputers, because when we talk about virtual machine clustering, virtual machines are basically virtual computers, and clustering means that we're connecting these computers together. So what makes a supercomputer? Well, when we think of supercomputers, we're actually thinking of enlisting more computer power. We're not thinking of one single machine where we add more RAM, where we add more memory, where we add more CPU power. We're thinking of individual computers connected together to perform larger and more complex computations. That's what a supercomputer really is. And you might have seen some supercomputers like IBM's Blue Gene. And what it ends up looking is you have these large black racks with a bunch of boxes. And these small boxes within these individual black racks, the small boxes are those gray boxes that you see in this picture, are individual standalone computers. And these standalone computers, when inside this supercomputer organization, are called nodes. Now, to explain how it really works, you have these standalone computers, and these standalone computers are nodes, and all of these nodes are connected to something called a switch. The switch is what you see on the right side of this screen. And that box, that device is a switch. And what a switch does is that with Ethernet or Mellanox InfiniBand cables, but you can think of those as Ethernet cables if you haven't heard of this thing called Mellanox InfiniBand cables. And these Ethernet cables are connected from each computer, each standalone node, and it serves as a hub point where all of these standalone nodes can talk to each other, can send bytes, can send packets, or take advantage of a networking library to send information to each other. So what we have is something called MPI. And MPI stands for Message Passing Interface because you can send arbitrary bytes to each of the computers once you have the switch, and you can ping each computer from another computer when they're all connected physically with the switch. But MPI provides a better way to send information from one computer to the next because it's not just a networking library, it's optimized for performance. It takes advantage of the fastest transport from one machine to the next machine, and it's a very universal protocol that's implemented in nearly or in all Linux operating systems. So what we have is when we physically connect these standalone nodes within the supercomputer together via the switch is just that hub point where all the information is going to the switch and going to their respective destinations. And we can use something called MPI run, which is a binary command when you install the MPI libraries. And MPI run automatically distributes to a number of cores or CPU processors that you want to distribute the command to. So in this screen, you see that there's an application called My App, and you can think of the My App doing anything from saying hello world or doing something complex like computing a molecular dynamics simulation. And with MPI run, you specify the number of cores with -np or just it's a flag to specify the number of cores. And the number of cores are the number of processors on the CPU. In this case, we do 4. And it automatically distributes to whatever machines are connected physically to the switch. So in this case, let's say I have 4 machines, and 4 machines are physically connected to the switch, and I can use MPI run with 4 cores to run my app, and it parallelizes the 4 cores so that my app runs faster and has a faster runtime. And that's what MPI really is. And you can use MPI, the message passing interface, within a programming language. Within a programming language, you have more ability and more power to exactly what conditional you want the program to react to what you're actually writing. In this case, in this image, you see an MPI Hello World program, which runs the program according to a couple of conditionals and specifies a number of cores within those conditionals. But in this video, I don't see this very often on YouTube videos. There's nothing that shows you the full process. How do you cluster machines? And it's hard to find this information. You can find it in blog posts, but in a video, that's what I'm showing you in this video. And so the breakdown of this workshop video is that number one, we'll show you how to cluster, how to connect two virtual machines together. Number two, we're going to set up an NFS server. NFS stands for Network File System, and it's served to create shared folders because the shared folder is important to share libraries, to share programs, to share things that you need to be accessed between and among all machines. And the third and final step is to run something with MPI to really see in action the machines running a program in parallel. So let's get started. First, we'll need VirtualBox. Now, what is VirtualBox? VirtualBox is a program that allows you to create these things called virtual machines. I explained it a little bit earlier in the first 5 minutes, and I said that virtual machines are basically virtual computers. So we'll get the Windows version because I'm on Windows, and I'll save it to my desktop. And this is a 100 megabyte file. We'll save it, and we'll run the executable. Now, in the meanwhile, you'll also want a operating system to put on these virtual machines because they're just computers, but they'll be empty. And we'll use CentOS. CentOS is a popular Linux distribution, and I use CentOS because I prefer it. And we'll use the minimal ISO. I've already downloaded it. It's 600 megabytes, but it's very small compared to a very big operating system that's normally 4 gigs or a little less. And you can install the minimal ISO. If you click on it, any of these links will download CentOS 7 minimal ISO, the latest version. Now, VirtualBox has finished for me, so I'll just open it up and make sure that you get this operating system or an operating system of your choice if you're more familiar with Linux commands. So I use Oracle VirtualBox, and I just go next. I leave everything by default. At this step, it says networking feature will reset your network connection and temporarily disconnect you. So make sure you're not downloading anything while you actually run this VirtualBox installation. And you hit yes, and you install. And you hit yes on any user account control. For Mac users, you just do the same thing as me. So you might have a different program that you prefer, but for this workshop, I'll show you VirtualBox because it's a fairly popular virtual machine program. And this should just take 1 second, and we can just hit finish and start VirtualBox after installation. Now, VirtualBox should pop up and it looks like this, and it's empty. On the left side is where your virtual machines will be, and on the right side is some description and some information about that virtual machine. But we have none. So first thing that we want to do is we want to hit the new button to create a virtual machine. And we type in CentOS-1, and for the type is Linux, and we'll use other Linux, 64-bit. And these are the configurations. So CentOS-1, Linux, other Linux, 64-bit. And we hit next. And for the memory size, all of these configurations you can leave by default, but if you have a weaker computer, then you might want to downgrade some of these settings. So I'll leave all these settings by default, and you have one virtual machine, but this is empty. And we need 2 virtual machines to show you how to virtually connect 2 machines together. So we use the same settings, and I'll just use everything by default and just hit create. So we have these 2 virtual machines, and they're completely empty. For the first virtual machine, we'll hit settings, and we'll go to storage. Now, this storage tab, you'll see CentOS-1.VDI. The VDI is your hard drive, or your virtual hard drive. Now, we want to click this empty disk, and we want to add the ISO, the operating system ISO setup. So we check on live CD/DVD, and we click on this CD icon, and we choose virtual optical disk file. Now, I have downloaded in ISOs folder on my desktop, and you just take the minimal ISO and you open it and you hit OK. Now for machine number 2 you do the same thing, and what will happen is we're just going to boot into that CentOS minimal ISO, and we hit OK for CentOS machine number 2. We start both machines because we're going to install CentOS 7 on both of these empty virtual computers. So you'll see the setup, and all you need to do is for each window which represents a machine, you just hit up and you enter. And you also do the same for machine number 2. Now it will go into the install CentOS setup, very typical, nothing out of the ordinary, and we wait until the setup pops up. So this is really step 1. You have to get your computers and you have to install the operating system on all machines. There are some techniques that speed this process, but we won't go into detail within this workshop. But in future workshops, I'll demonstrate to you. So on both machines, you'll see the prompts, and we'll select English as our language, but we scroll down and hit continue. And we'll also do it on CentOS machine number 2, hit continue. Now for installation destination, we click on it, and all we do is hit done because we can leave by default that setting. And we hit begin installation. And we also do the same thing for machine number 2. We hit installation destination, and all we do is hit done because we don't need to change any of these settings. You can also change your date and time zone. For me, I live on the East Coast, so I'll use the New York time zone. I hit begin installation. And on both machines, you hit root password because you need to set a password. So I will set a password, and I will hit done, and I will do the same for machine number 2. And hit done again, and I'll wait until the installation finishes. It takes about 5 minutes for this minimal ISO to finish. It'll be longer if you use your own preferred operating system that's not a minimal ISO. So I'll skip ahead for this part and come back once installation is done for both machines. Right, both machines have CentOS installed, so we go to the bottom right and we hit reboot. And both machines will be rebooting to CentOS. So we can wait a second for it to reboot, and we can show what we have currently. We hit enter on both machines to go into CentOS Linux 7. And we wait a couple seconds for CentOS to officially boot up. Now, it says localhost login. The localhost login is root, and the password is whatever you configured. And you're on the machine, but nothing is, it's just completely minimal, so we need something on the machine, because one thing that we need is internet connection. So when you install minimal CentOS, let's just try ping. So ping is a command on Linux machines, and also on Windows and any other machine, that allows you to ping some bytes to an IP address. And the IP address we'll ping is Google's, and it says network is unreachable. So we don't have internet access on either of these machines. Now we want to shut these machines down, so we power off both machines. And we have to change some settings on the machines themselves to get internet access. So go to settings, and before we actually get internet access, we want to go to storage, and we want to click on the CentOS minimal ISO with the disk image, and we uncheck live CD/DVD, and we remove disk from virtual drive because we don't need this anymore since CentOS is already installed on both machines. So we hit OK on both of them, and we just remove the CentOS 7, and we hit OK. Now go back to settings and go to network, And in network, you'll see something called NAT. Now, what NAT means is it stands for Network Address Translation. And what that does is that this virtual machine will look at the host operating system for network connectivity in the network information. So, for example, I have Windows 10 as my host operating system. It's the operating system that VirtualBox is on top of. And NAT will look at my Windows 10 operating system, and all the bytes will go from my network from Windows 10 to the individual virtual machines from VirtualBox. That's all there is to it. Now, on you can set additional adapters. For example, we'll have NAT and we'll use this for network connectivity. But how do we connect CentOS machine 1 to be able to talk to CentOS machine number 2? We have to set something called a DHCP server. And DHCP, if you've seen it before, you might have seen it while configuring Wi-Fi information. In DHCP, you can understand it by its automatic settings for IP address and different network configurations. So the reason why you set up a DHCP server is that all the machines that are connected via the switch, if we're thinking physical connections, need an IP address. They need a destination. They need a location IP address, right? And so we use the DHCP server to automatically assign IP addresses. You could use static IP addresses, but that's always inconvenient. So we use DHCP server to automatically assign these IP addresses so that each of these machines has a destination IP for communication, right? So how do we set up a DHCP server? Now, generally, on a physical machine, the way you set up a DHCP server is that you need to set it up actually with some libraries and some packages on one machine, and then all the other machines are connected to it. So that's the physical process, right? But since we're doing virtual machine clustering, what you do is you open File Explorer, you go to local disk, go to users, oh, not users, I mean program files, go to Oracle, and go to VirtualBox. So this is the directory that you want to be in, the folder that you want to be in, VirtualBox, which is in Oracle Program Files Local Disk. So what I want you to do on Windows machines is you hold the Shift button and you right click. Now when you do that, you'll have this extra option. It's called Open Command Window here, and you click on it, and a command prompt pops up. So we'll set up the DHCP server, and on VirtualBox, they actually have a command that sets the DHCP server with one line. So I've been writing this blog post for all of this information because it's a lot to take in. So I'll leave it in the description, and you can use it as a reference. Now the command is called v capital box capital manage space DHCP server add net name, and we'll call it intnet IP, and we'll give it a net mask, and we'll set a lower IP. The lower IP is the range, or the lowest range from which the IPs can be assigned for any machines under this network, and we'll set an upper IP to allow up to 10.0.1.200, and then finally we do a -- enable. Now here's the command. You can pause the video or you can just visit the blog afterwards, and you hit enter. Now the DHCP server is set up, but we need to connect the two virtual machines to that adapter. So we go to adapter 2 and we enable network adapter, and we select internal network. Now for internal network, it'll automatically assign to the name of the internal network if you only have one of them, and you can just hit OK. And for the second CentOS machine number 2, you go to network, adapter 2, check internal network, and hit OK. Now we can start both machines. So we wait for both machines to start back up, and we hit enter on both machines, and it'll boot into CentOS 7. After waiting a while, we log into root again, and we type in password on both machines. And to check all the network adapters, and they're also called network interfaces, you type in nmcli space D. And you can see that there are 3 network devices. The 2 that we will pay attention to are the ones that start with ENP. So one of them, you'll see that it's called S8 for the last 2 characters. And for the S8, it says wired connection, it's connected. And this is actually the internal network, the DHCP server related network. And it says it's connected. So, but for S3, it says it's disconnected. So why is the NAT disconnected? Because there's actually a configuration in minimal CentOS that you need to change to actually get access to the internet. And this happens only for minimal CentOS, at least on minimal versions of a Linux operating system. So we'll use a text editor called Vi. And you can text edit any file, but the file that we want to text edit is in etc sysconfig network-scripts and then en, or it's not called en, but it's called if cfg enp 0 and tab button autocompletes if you did not know that. So this is the file that we want to adjust, and we hit enter. Now with Vi, how you control Vi if you haven't done it before, up down goes up and down, left right goes left and right. But to edit files, we have to go and press I. I button on the keyboard stands for insert mode. And once you're in insert mode, you can go left, right, but we want to backspace on the no, on the very last line where it says on boot equals no. We want to change it to on boot equals yes. And to get out of insert mode, you hit the escape button at the top left once, and you type in colon. A colon appears at the bottom of the screen, and you type in WQ. W stands for write, Q stands for quit. And this is how you save and quit after you've adjusted file. So once you've done that, you can type in a command called systemctl. Systemctl controls all the system start, restart services. So for example, we want to restart the network because we adjusted a network script from the interface that's called enp0s3. And what we've changed is that we've changed and said that on boot equals yes. We want this network to be on, this network interface to be on when we start the machine. So we use systemctl and we restart network. And it just restarts the network service. And we hit enter. And so now, if we ping Google 8.8.8, we can see that the ping actually goes through 64 bytes, and we use Control-C to exit this command because we already have verified that we get 0% packet loss, and the ping actually goes through. Okay, well, we changed the same configurations to CentOS machine number 2, so I'll quickly do that. And like I said earlier, all of these commands will be in the blog post or in the YouTube description. Change this to yes, WQ, and we do systemctl restart network. And we hit enter. And we test ping Google's IP, and it works. Now, we test the DHCP server and the internal network. So the reason why we tested the DHCP server and we recreated it, because we need to be able to ping from CentOS 1 to CentOS 2. Bytes and packets should be able to transfer from one machine to the other machine, and we're simulating this physical connection to a switch between the two machines. So if we do nmcli space D, we can see that S3 interface is now connected, but we can see that S8 was always connected. So we need to check the IP address of both machines. So we type in a command IP addr space show. And this is the command for CentOS to show your IP addresses. And you can see that there's 3 network interfaces, and they're labeled 1, 2, 3. and we check the one that is labeled S8. In this case, we see that for CentOS machine number 1, after iNet, we see that the IP address is 10.0.1.2, and for machine number 2, we see that the iNet is just one number above. So with the dynamic configuration of the IP addresses, it just increments, right? Depending on what your range was. So from machine number 1, I can ping machine number 2. So machine number 2 was 10.0.1.3, and we ping. And we can see that bytes are transferred. Arbitrary bytes are transferred within the internal network, within the DHCP server and client connection. And we hit Control C to exit. And we can see that this actually works. So we finished part 1, establishing the network access from one machine to the other machine. Now we'll move to step 2, getting the NFS server and client to get shared folders. So for step 2, I'll move it over here. The first thing that we want to do is we want to use a command called yum. So yum for CentOS is a package installer. And we use yum install nfs-utils space nfs-utils-lib space -y. And with yum, we'll install nfs-utils. NFS stands for Network File System. I said this before. And these two libraries is something that we need. -y means that we'll auto-confirm. If it gives us a prompt, it automatically confirms that prompt. And install is just for installing. And we hit enter. And we install these two libraries, and yum helps us install all the dependencies of those libraries. So there are several package dependencies with NFS, and we wait until this completes. Now, after waiting until this completes, it says complete. So we want to use systemctl, and we want to make sure that we start the service. Now, there's a service called RPC bind. And RPC bind is a type of port mapping, and it makes sure that the ports are correct. And we also start the NFS server. So how NFS works is that you have something called an NFS server, and you have things called NFS clients. So what an NFS server is that it's where the folder was actually generated, and what the NFS clients are each of these clients are connected to that NFS server, and they're just peeking at the NFS server folder where the shared folder is and looking at what's inside it. And that's how the shared folder actually works. So we hit enter to start that service, and we use up to go to the previous command, and we erase start, and we type in enable. And we enable RPC bind in NFS server, which means that it'll automatically restart when we have RPC bind in NFS server. So we hit enter, and RPC bind in NFS server will start when the machine starts. Okay, so after you start the two services, now we need to create the directory. So where are we going to keep the shared folder? Well, I'll create a shared folder called in/NFS share. And after you create the folder, you adjust a file in etc using vi, and we text edit this exports file. So inside the text export file, this is used to, it's kind of a config file where you type in what folder you want to share. In this case, it's /NFS share, and you type in the IP that you want to share it to. In this case, it is 10.0.1.3. And I recall this IP address is the IP address of CentOS machine number 2. And for the settings that are put into parentheses, we do RW, which is read write. We do sync. We do no_root_squash. And we do no_subtree_check. We do the closing parentheses. Syncs the files in the shared folder. No root squash. Make sure that on the root user we can access the shared folder. And I don't recall what subtree check is, but you can look it up. And we hit escape, and we do :WQ again to save and quit. And afterwards, we type in a command called export fs-a, space dash a. And this reloads that exports file that we just created. Now, when you're using NFS, it's really important, and I came with this complication where you have to set up the firewall. You have to add the services because the firewall for minimal instances usually will block NFS and will block RPC bind, and you need those to be able to use NFS shared folders. So we type in a command called firewall-cmd --permanent --zone public --add -service equals NFS. So we're opening a role for NFS and we hit enter and it says success. We type in or we hit the up key, and instead of NFS we type in mount D for a mounting command, because what you're doing with the client is basically you're mounting the folder onto the client. And it says success and we hit up again and we type in RPC bind for the port mapping and we hit enter again. Then we reload these new rules with firewall-cmd space --reload. We enter. And we can restart NFS. So we use systemctl restart NFS -server. And we hit enter. Now for machine number 2, which will represent the client, you do some of a similar thing, a similar process. First, you install NFS libraries, and you do the -y, and you use yum to do the installation, and we wait until all the dependencies are installed on CentOS machine number 2. There are ways to automate all of these steps, but they're beyond the scope of this workshop. So we install NFS on machine number 2, and what we do now is we make a directory with mkdir, and for make directory we're making a folder where the shared folder from CentOS number 1 will appear on CentOS number 2. You have to actually make the folder for it to appear on both machines. So you make directory and you do -p and you put /mount. I'm going to put in /mount NFS and NFS share. So what the -p flag here does is that if any of these 3 folders do not exist already, it will create the folder for me. So if NFS did not exist, then it will create this folder first, then it will create NFS share. And this is a useful command for creating a succession of folders. And we hit enter. Now after we make directory, we show mount -e and we type in the IP address of the main machine of the NFS server, which is 10.0.1.2. This shows if we can actually mount from our machine to CentOS machine number 1. And it says that there's an export list which looks at the export file in CentOS machine number 1, and there's a /NFS share for 10.0.1.3. So we know that we can access this IP address of the server. But to double check, we use a command called rpcinfo -p 10.0.1.2. So this command looks if the ports are actually open and we can communicate via what ports. And we can see that there's NFS, mount D, and a port mapper, which is all that we need to access CentOS machine number 1. So now we use a command called mount 10.0.1.2. So from machine number 2, we mount to the server IP address, and we use colon to specify what folder that we want to mount from the main server. And that folder, because we created a folder called /NFS share, and the folder that we want to create on our machine, or mount on our machine, is /mount /NFS/NFS share. So what we're doing is we're mounting the folder from machine number 1 to machine number 2 to replicate this shared folder. And we hit enter. And if everything's fine, then it should just automatically proceed. And to check if it was actually mounted, we do a command called df-h to see all of the drives or all the file systems. And we see at the bottom there's 10.0.1.2 colon slash NFS share. So that is actually machine number one. So how do we verify that the shared folder is actually working? Well, we use ls and we cd dot dot slash. ls lists all the contents of the directory. Cd is for changing directories, and dot dot slash is to go to the directory before or down. And we do ls and we cd NFS share. So if we do ls, nothing's in it because we didn't create any file in it. But if we use a command called touch and we create a file, in this case, I'll just create a file called microwavesam.txt, and we do ls again, we'll see that on our machine, on the main machine, microwavesam.txt appears. Now, if we change directory on machine number 2 to where we mounted the folder, which is in mount NFS, NFS share, and we hit enter, and we do ls, we can see that that file is created. So this verifies that the shared folder actually worked. But then, just to double check, we'll actually adjust this file with vi, and we'll say, type in microwave sam, and we'll save it. And then on this second machine, we'll actually open the file with vi, and we'll see that microwave sam's in there. So a shared folder has been created, which completes our second step. But there's one last configuration that we should do. And what that configuration is that we need to leave NFS on. And how we do that is on the client machine, on CentOS machine number 2, we adjust the file vi etc fstab. So this file is something that mounts things automatically for us, because if we were to restart both machines, then we would have to type in the mount command completely, and that's always annoying. So we go to the bottom and we type in this command, or type in this line. So first, we want to mount from 10.0.1.2 the server colon slash NFS share, which is the folder that we're looking from the main machine, from CentOS machine number 1. And on our current machine, we're going to mount it towards NFS share. And then there are some configurations. So the rest of the configurations is NFS, auto, no, A-time, no lock. This will be in the blog post, by the way, so you can just copy and paste, but I'll have to write it manually. Okay, so that's the command, and yes, so that is correct. I was double checking. And then we save this by :wq. Afterwards, if we do a command mount-a, then it automatically mounts everything. But to verify that this is working, we will restart both of the machines. So we power off both machines, and we go back to Oracle VirtualBox, and we start both virtual machines again. And the first thing that I'll show is that once we go into both machines, CentOS, you'll see that the NFS is not actually connected. But, okay, so on CentOS machine number 1, we'll go onto user, and we cd slash NFS share, and we ls. So microwave sam text is in there because this is the NFS server, and it's where we actually created the file. So on the second machine, we also cd, but to the folder that we created, which was mount NFS share. And we ls. So actually nothing's in there, right? Because like I said before, when you restart the machine, the NFS just is not mounted. So because if we did not do the changing of etc fstab file, then what we have to do would be we would have to do this whole mount command 10.0 blah blah blah, and we'd have to manually write that command every single time we restart. But because we changed that fstab file in etc, then if we do mount space dash a, it mounts everything, and we do ls, well, okay, that did not work as I had hoped. Let's get out of this folder and type in mount dash a, and let's see if it actually changed the file. So yes, so you have to be outside the folder. So the mistake that I made was that I was inside NFS share, and when you're mounting something, you cannot be inside the folder. So after I cd // to get out of that folder that I was going to mount into, and typed in the mount -a command, then I mounted the line that was in the fstab, and then the NFS shared folder is reestablished. And then you can just proceed. If we open microwavesam.txt with the vi command, we can see in microwavesam, the shared folder is established. So we've finished step 2. Now the third final step is to show you how to use MPI. And we'll show you how to use MPI on a simple program, and you can begin with parallel programming. But we've set up the connection between two virtual machines, and we've set up a shared folder, which is important for sharing libraries and programs.